Okay, so I'll begin. So I'll be talking about something I've called deeper discussions, and really they are a teaching strategy, a kind of activity which are trying to develop higher order thinking skills such as problem solving. I've highlighted that here, but I'll also there should be another one there, I think, in this subtitle, uh, critical thinking, and those are what I'll be focusing in on today. It also plays into developing other kinds of skills as well, such as group working and communication skills. But we'll mostly focus on the cognitive skills because that was the main motivation, if I'm honest. So the objective is, of course, to explain what these deeper discussions are. I'll be abbreviating them by DD and justifying them. By justifying them, I mean what's the motivation behind them, outline what they are, as I said, and explain the theoretical underpinnings of these activities. So, first of all, the motivation for this. So, as I said, the main motivating factor behind developing these activities was to focus on higher order thinking skills, cognitive skills. And I've outlined two, the main two that I really thought about. And if I'm really honest, the main one I thought about is problem solving, but it has become very apparent that actually critical thinking is also a part of it. So I put up two definitions. I put up definitions or descriptions of these skills as can be found in some literature. So the second one for problem solving is my sort of interpretation of Pollier's heuristic. So I'll leave you to read through that. I think probably problem solving doesn't need to be gone into so much, but what I'll mention about critical thinking, because we don't always think about critical thinking in mathematics, and what makes critical thinking perhaps different from problem solving in this context, because it requires, as this description here talked about, interpretation and an evaluation. So, if what will be important with critical thinking, what you often have, and this became apparent to me when I was when I entered when I entered pedagogy, is that you have different arguments and different approaches to things, and some are better than others for a given context, right? We know that if we look at educational literature. Well, I'm we have a similar sort of phenomena that occurs with mathematics, where we have, and we'll see an example of this, where we might have different interpretations of a word, of a thought that we have, which is maybe more vague, and then we crystallize it into something explicit, and then that has. You might think, oh, is that interpretation better or worse or more appropriate? But also, you may have different proofs, and different proofs can be of different value, let's say. We'll come to that. Well, anyway, it probably doesn't need me to say this, but it is important to develop these skills. It's important that our programs develop these skills because employers really do prize them. I've cited two bits of work here that puts problem solving in particular as one of the most desirable skills for employers. And these skills are important for seeking truth in a broader context, of course, as well. And that's as far as I'm concerned. So this is partly my philosophy here on academia, but I think this is a core facet of academia and what we should be training students up to try and ascertain, try and figure out in any given context. And of course, once you start thinking more broadly outside the terrain of mathematics, trying to ascertain what the truth behind a matter is becomes a bit more blurry, a bit more gray. And so that to me really stresses the importance of thinking about how we develop these skills, because you need those to try and approach the truth at the very least, whatever the truth may be. And but at the same time, yet I would argue, once again, part of my perspective here, that most of our teaching really focuses on, and we think about or what things do students need to know rather than skills that students should acquire. And so there's a difference in fundamental perspective there. So, okay, how did I try to address this? So, what are the core underlying principles that I went in with? So, in view of what I said in the previous slide, what I wanted was some kind of strategy that really puts skills at the heart of it. And I think once you start thinking of developing skills, you naturally, well, I naturally thought of apprenticeship models of learning. And there is a large body of literature around a concept called situated learning. I put up the authors here, and there will be references at the end of this slide. I'm sure the slides are shared to all this stuff. And this model, in a very rough sense, what it does is treat students as apprentices of a community they're trying to enter. So mathematics students are apprentice mathematicians at the periphery of the community of mathematicians. Now, you see that as a shift in perspective in many ways, but one of the things that really shifts perspectives to one of the ways it shifts one's perspective is, well, for legitimate learning, then we have to be asking students to undertake tasks of the kind that mathematicians do. Okay, so okay, there is a body of literature in cognitive science that says that students, novices of a field, cannot, their brains are organized in a different way, so they cannot do exactly what the experts do. But the idea is, okay, how can we bring down what we do down to their level where they're currently at? So it's replicating the kind of thing that we do, maybe not exactly the thing, not a research problem, basically, but the kind of thing that we do for our students. And what is it that mathematicians do? Well, as Halmos says, we're problem solvers. That's what we do. And in fact, I go a bit further than that. I don't think there'll be much disagreement in this, that we generate knowledge by problem solving, right? That's my entire experience of research mathematics. We ask problems, maybe in a vague sense, but then we generate knowledge by trying to solve those problems. Okay. So that in turn leads us to think about how we can develop problems that would develop a teaching strategy that authentically replicates what we do. Well, that led me on to problem-based learning. And I say this led me onto it. In truth, I actually experienced problem-based learning in a sixth form college that I taught before I actually saw the literature on it. But nevertheless, the literature reflects what I saw. And the problem-based learning can be described, once again, rough description, as generating knowledge through solving problems. So you ask students problems and knowledge is generated and the learning is generated in that way. Um, so there's a body of literature that talks about, well, the pros and cons of this, but I'll leave that there for now and perhaps come back to that later. And one more thing, which is may seem like a slight aside, may seem quite different to the previous two. Another core tenet that came up pedagogy that I decided to leverage was dialogic teaching, which is in the rough words of Alexander, paraphrasing what Robin Alexander says, who originated this, who was the founding father of dialogic teaching, is to leverage classroom dialogue to model and practice thinking skills. Now, why is this important? Well, if one studies certain theories of thinking and understanding mathematical thought, there's a school of thought that says that from the likes of Vygotsky and Safrad, that says that thinking is fundamentally dialogic, and some of them even go as far as to say that there's a large component. Vygotsky's big on this. He says there's a big component of learning and thinking, which is social. And so to practice thinking skills, since they're reflected in dialogue, maybe internal dialogue, the idea is to bring out that internal dialogue and make it external and thereby practice it by engaging in dialogue, i.e., thinking of others. And also uh, for the teacher to reflect their thinking skills, to manifest their thinking skills, model their thinking skills by the dialogue they're using in class. So those were the underlying principles behind the strategy. So, okay, that's a lot of theoretical blah, blah. So what is the strategy? So the strategy, and let me just have a quick look at the time. Okay, so the strategy in a nutshell, the idea is that, well, it won't surprise you if I say it's a series of problem-solving activities where students attack deep. Okay, that's maybe not that surprising given the name, but this is maybe where it starts getting a little bit different from what we normally do. These problems are often ill-formed and open, and these problems they address in groups as well as individually. And also they are embedded into the narrative of the course content. So they're not a stand aside, they're actually fundamentally a part of how the course is taught and how knowledge is generated, and that is replicating the spirit of problem solving learning. So let me just give an abstract outline of how this works. So in the initial instance, these problems are shared in course notes at some point in the course. Then later on, normally the week after, they are discussed in tutorials using class discussions and small group discussions. And then they are then revisited. The answers are then used as foundations for future learning in future lectures. So, okay, let me talk about a very concrete example that I've used. Before I do, of course, the fact that we are revisiting this in future learning points shows that, in fact, we are also using interleaving strategies uh, in this, which is a strategy for those that have seen it, which is supposed to be enhance understanding and knowledge retention. Okay. Well, okay, let's give a very concrete example of a problem. Okay. So here is a problem. So this problem, so it says above, we stated that this is pulled from the course notes. So in the course note, it was stated that complex conjugates give us another solution of certain equations. So the equation was a quadratic equation with real coefficients, quadratic polynomial equation, right? And the question is, how broadly is this true? That is to say, given a polynomial f of x such that f of x equals 0 has a complex solution, is the conjugate a solution of that equation as well? And then there's a hint. So for a bit of context, this is from a foundation year course, the second semester of a foundation year course, and this follows a lecture where complex conjugates are lectures where complex conjugates are complex numbers are introduced, and they are actually introduced as solutions of certain equations, and that's where the spirit of this question comes from. Now, there are a few key features here that I want to really point out, and I said earlier on that these problems tend to be ill-defined or slash and open. Well, here's an example of where this is ill-defined in this case. So the term I've used the term polynomial, but you may have noticed, if I haven't bored you too much and you haven't fallen asleep yet, that I haven't that I'm being vague here, and I have not mentioned what kind of polynomial this is. In particular, I haven't mentioned the polynomial ring, where the coefficients are coming from. in other words. Okay. So, okay. So why do this? Well, this is once again, so this, so there are three reasons I've given here for doing this. Firstly, this is to reflect how mathematicians think, because we think in terms of these broad questions, and that's why I've asked this question in this way initially. How broadly is this true? And then I unpacked it because I thought it needed scaffolding in this particular case. Um, but of course, we think in terms of in broad terms like this, and then we try to think of specifics, maybe try and then we go from a broad question, maybe a vague question, to more concrete questions. So this is trying to replicate that authentic spirit of question asking that we have as mathematicians. And then this also facilitates a critical discussion of how this word might be interpreted here, polynomial, in particular, what kind of coefficients we might want to consider here and why, okay, and what that means for the answers. And indeed, the answers depend on how we interpret this here. And another feature, and following on from that, but also even once you make this concrete, what kind of polynomial you have over here, of course, this problem would still allow for different approaches. So one approach that students tend to go for almost automatically here is to try and use the quadratic formula to show that this is true. But another way of trying to show that this is true in the case when you have real coefficients, of course, is to use the properties of complex conjugates. That's very nice when that happens, because students get to see, well, both provide you a proof in the case that f is a quadratic polynomial with real coefficients, but not both proofs are not the same in terms of power, right? Because the complex conjugates, the properties proof, the proof using the properties of conjugates, of course, generalizes at least far more easily, right? But in general terms as well, they're seeing is we don't have equations for higher order polynomials, for higher degree polynomials. So, okay, that's the problem. That's the kind of problem we're thinking of. But then the second part I said was we then we really attack this in tutorials. And the way these are structured is very intentional and very discussion and dialogue based for the reasons I mentioned before. And that's particularly to tap into dialogic teaching strategies. So initially, there's a class discussion where we might identify ill-defined ideas, define key terms being used, and of course, consider prerequisites. So that's done as a class. Then students are asked to consider this once we have a clearer sense of what the problem is. Students are asked to consider this in small groups. They discuss their ideas, at which point tutors, those are those leading the tutorials, or GTAs helping out in the class, circulate and talk to groups, and they use something called the Socratic method. I've asked them to use the Socratic method, which is something that we'll come to if there's time, but I'm not going to go into it now for the sake of time. But in short, it's a way to help students to use dialogue, questioning in particular, to help students really unpick their own thinking, really identify what suppositions they are using and the logic they are using, and thereby refine their ideas, hopefully. So this phase has two roles here. So it's to help students understand their own thinking, practice those thinking skills through dialogue and through using dialogic teaching, but it's also actually for the tutor to pick up on different ideas that are circulating around the class for phase 3, which is then when the tutor brings back the class for a class discussion where they weave together the different ideas that have been suggested in the class, hopefully, and trying to come to, well, possibly some kind of answer, but at least some kind of progress, maybe reformulating the problems if needs be. And that's why there's another arrow going back to phase one, where you might start the process again. So um, let us now consider this, what this structure looks like with this particular problem. And this is actually how it panned out when I used this in this year's tutorials. So in the initial discussion, phase one, there was, in fact, as we mentioned, there was this the notion of polynomial, which was left vague. So that's picked up on in this.
Nikesh,
Yep.
can can you begin to wrap it up, please?
Yep. Okay. So let me
Okay,
just
thanks.
put this up. Right. Okay. So this cycle here shows how this discussion proceeds. So initially, this polynomial is um, we identify what this polynomial is. They discuss it, and in this discussion, the idea when of the diff where the number what these numbers should be normally arises, and therefore the problem is then made more exact by saying there are two subproblems when we have the two different kinds of coefficients, and then the cycle begins again when they have once they have these two concrete subproblems. Well, okay, so let me finish this off. I won't, this doesn't really need to be said. So I will leave it with this. I will just put up this slide, in fact, for future thoughts. So moving into the future, thinking about using heuristics and actual heuristics such as Polya's heuristics in an explicit manner, as mentioned on the slides, and then thinking about how we can assess these skills, seeing as they're a core part of the course. I do this to an extent already, but I think it can be made more targeted, let's say. Okay, let me finish there.
Okay, thanks very much. People can uh, share their appreciation using um, the button I can't find now. I managed to lose it. The reaction button. Uh, okay, so if you've got any questions, please put them in Q&A. There was an unanswered question from the Q&A last time, and that's now been answered. So if you should be able to, people should be able to look in that and see it under answered. But we'll see if we've got any questions. I mean, well, maybe I can ask a quick question then. So you sort of give them a question, and
Mhm.
then they can iterate that. Do you ever say to them, "Come up with your own questions, then we'll iterate on that"?
No. And admittedly, well, no, that's not completely true. Um, so when in with these problems, sometimes it's a case of the students come to an answer for, and then I have, and then they come to an answer, and that seems to, and genuinely seems to wrap up the problem at hand once it's been made precise, of course. And then the question arises, well, okay, now how might you extend this idea? Okay, what happens if you, so with this example that I spoke about earlier on, where we normally land, so I'll put this up here since I didn't get to show this slide. So where we do normally solve this for answer this question for quadratics with real coefficients, and at that point could ask the student, okay, how can we extend this? And they, a lot of them think, well, okay, higher order polynomials, right? Okay, how do you do that, right? Normally they solve this for using the quadratic formula, which is what makes that question so interesting. So it happens in that sense, but there isn't, say, an allotted tutorial where I just go, here's what questions do you have?
Yeah. So that is a bit tricky.
Mm.
We haven't got a question in the Q&A, but somebody's put something in the chat, so I'll go with that. So, it says, are the tutors PhD students or more senior? And do you train them in the dialogic method?
Yes, I do. And yes, they're GTAs. In fact, not that it's been an option, but I prefer it to be that way. In some sense, the GTAs are are more receptive and more of a clean slate. That's my personal take. But yes, no, I do train them. I we sit down before the so this year in particular, what I've done is shift to larger tutorials to ensure that there is consistency in the delivery of this. We're in a room that has various tables and what have you, and I have GTA circulating, and I've but before the start of the semester had a specific meeting where I went through the Socratic method and discussed it with them.
Right. Okay. Good. So yeah, maybe we should, because we're pushed for time, maybe we should just draw that to a close today, and let's thank Nikesh again, like so.